All right, so we are continuing with Chapter 1. This is the third day of notes. So your homework tonight will be day 3. We are going to use equations to solve word problems, okay? So you should have these in your notes, but it looks like a number's missing in each. So just fill in the blank. The sum of 92 and 3 times a number is 128. Find the number. So I need to start by setting up a let statement. So I'm going to let n equal the number. Sum means what? Add. 3 times a number means what? Multiplying by 3. Is means what? Equal sign. Here's my equation. 92. Sum means plus. 3 times a number means 3n. Is my equals 128. And now it's just a two-stepper like yesterday. How do I start this one? You subtract 92 from both sides. The 92s are gone. You have 3n equals 36. Divide. 12 is my number. Raise your hand if you have a question on this one. All right, number 2. If you decrease the product of 16 and a number by 52, the result is 300. Oh, there's a lot happening. If you decrease the product, what does decrease mean? Subtraction. What does product mean? Plus. Multiply. All right, let statement. Now, here's where we need to start thinking about this. If I decrease the product, so what am I doing first, the product or the decreasing?
Product.
The product. So I'm going to write the multiplying first. What am I multiplying? 16 and the number, but I'm letting the number be what? N. So I'm going to have 16n, then what? Minus, then the 52 equals 300. Very, very good. All right, how should I do the next step? Add 52. You got to undo adding and subtracting first. So I'm going to undo the subtracting 52 by adding 52. Then what? Divide both sides by 16, and what do I get?
N equals 50, 44.
22. This is 22.
Oh, it's 16, yeah, 22.
16 is the product. Oh my God.
The answer's not coming up. There it is. Sorry, iPad delayed. 22 is correct.
I thought it was 8.
What are your questions? All right, number 3. Harry and George are twins. Their brother, who is 15 years younger than the sum of their ages, is 25. How old are the twins? Now, the good thing is we're talking about 2 boys, but they're twins, so what do we know about their age? It's going to be the same, all right? So, 15 years younger.
Minus. Or subtract.
Their brother is 15 years younger. than the sum. So if I find the sum and I take away 15,
So it'll be like X.
now it kind of depends which side of your equation you want the 15 to go on. So there's a couple different ways you can set this one up.
Right.
I'll show you this way. Okay. So yeah, if you add so they want the sum of the twins' ages. So I'm going to use X if you want to use age for like A for age or T for twins. So when you take the sum of their age, the brother's 15 years younger than that. So you can subtract 15 from both, from their sum. I've seen people set this up where they do it, the 15, they just start it on the other side. They're like, okay, well, if he's 15 years younger, if you start with his age and you add 15, you'd get the brother's ages, you know what I mean? So it just sort of depends where you want the 15 to be. This is the most common way to do it since it says younger. But if you had like 2x equals 25 plus 15, that would be fine too. You get the same answer. Does that make sense?
Yeah.
Okay. All right, so sum of their ages. So x plus x is 2x. Now what? Add 15. Divide by 2. How old are the twins?
20.
20 years old.
I mean, the brother is 5. That's a little late.
No, the brother's 25. It says it in the problem. Their brother, who's 15 years younger than the sum of their ages, is 25. So the twins are both 20 and he's 25. But when you add their ages, he's 15 years younger than that. I know, crazy.
It's like 2 twins. That's not possible.
Questions? Number 4. Does anyone know how to find perimeter? You add all the sides. Very good. Now, if you add the length and the width and the length and the width, you end up with this. 2 times the length plus 2 times the width. It sort of combines the like terms already for you. So some people just say like L plus W plus W. Length and length, width and width. Or you can say perimeter equals 2L plus 2W. 2L plus 2W is the way I will write it in this class, okay? All right, so I am going to call the length L. So the perimeter of a rectangle is 130 meters. If its width is 12 meters, find the length. So I don't need a variable for the width because I already have it. See, it's right here. So we'll start with the original formula, 2L plus 2W. W already know, though, it's 12. L is what we're finding, so I am going to let L stand for the length. L equals the length of the rectangle in this case. And then you just plug in what you know to the P equals 2L plus 2W. So perimeter, 130, width, 12. L is length because I don't know that, and now I can solve. How would I solve this?
You would multiply the 12 by 2.
Yeah, just multiply the 12 and the 2. Then what?
Subtract the 24.
Subtract the 24. And then divide it by 2. So I am saying the length is 53 what? Meters. Phenomenal. How you guys doing on this?
I got everything right.
Yeah.
I think you're making good time though.
What time do we get on?
But no 5.
All right. Next, we have consecutive integer problems. You have like 3 boxes in your notes. You need to write all of this down. I'll give you a second. So the word consecutive is right in a row. Consecutive integers are just integers that are right in a row. So like 3, 4, 5 would be consecutive integers. Consecutive even integers are even numbers that are right in a row. 2, 4, 6, 8. Consecutive odd integers are odd numbers that are right in a row, like 1, 3, 5, 7, 9, 11, and so on. Okay? So when you are going up in just consecutive integers, you're adding how much each time?
1.
1. You're just adding 1 each time. So if you start at the first integer, we can call that x. The second integer, you just add 1 to the original. The third integer, you add 2 to the original. Okay? Even and odds are the same idea. We just jump up a lot faster. So to go from 2 to 4, you have to add 2. But then to go to the next one, you'd have to add 4. Odds are the same way. Even and odds, you set them up the same. In one case, you'll get an odd answer. In one case, you get an even answer, okay? So just make sure you get all this in your notes. We'll refer back to this chart a lot while you're getting the hang of this. Number 5 says find 3 consecutive integers whose sum is 24. Consecutive integers are integers right in a row. So I'm going to call the first integer what? X. I'm going to call the second integer what? X plus 1. Consecutive integers go up by 1 each time. Think of like how would you go from 2 to 3? Now, the third one's trickier because you have to start back at the x. So to go to the third integer, you'd actually have to add 2 to the first integer. Okay? Now, sum means what? Add. So I'm going to add x, and I'm going to add x plus 1, and I'm going to add x plus 2, and that should equal 24. It is 24. So this spot represents my first integer, second integer, third integer is 24. What's x plus x plus x? 3x. What is 1 plus 2? So 3x plus 3 equals 21. No. Whoop. I got a step ahead of us. 24. Then what? Subtract 3 from both sides. Divide both sides by 3. X is 7. But I'm supposed to find how many integers?
3.
3. So this is my x. So what's my first integer? 7. What's my second integer? 8. What's my third integer? 9. Good. And if you plug them back in and you don't get 3 numbers that are right in a row, you've done something wrong. And if you add those 3 numbers back together and you don't get 24, you've done something wrong. These are tricky. We will practice these a lot today and tomorrow. Just remember the setup. If they're consecutive, you do x, x plus 1, x plus 2. If there's 3 of them. If there's 2 of them, you just do x and x plus 1. I don't know. All right, number 6. Find 4 consecutive odd integers whose sum is 96. Those are the steps we're going to follow. First, I need to set up my let statements. So I'm going to call the first integer what? X. X is always the first one. Now, how do you go from one odd number to the next odd number? You add 2. So I'm going to add 2 to the X to find the second odd. Now, if you wanted another odd, you'd have to add another 2. But what's 2 plus 2? 4. Then you'd have to add another 2, which is 6. Now, students always get hung up on this because they're like, well, odd integers, these aren't odd numbers. It will work out to give you an odd answer. If it doesn't, you did it wrong. But if you're counting by odds, you're not having consecutive odd integers. If you're adding odds, you're going to flip-flop back and forth between even and odds. So don't do that, okay? When they're even consecutive integers or whether they're odd consecutive integers, this is the setup. The only difference is your answer even or odd when you get there. And if it's the wrong one, you made a mistake somewhere. All right. Questions on this setup so far? Sum means add. So I'm going to add x and x plus 2 and x plus 4 and x plus 6, and it is 96. What's x plus x plus x plus x? 4x. What's 2 plus 4 plus 6? 12. So 4x plus 12 equals 96. Then what? Subtract the 12 from both sides, and you get that 4x equals 84. Then what? And what do you get? 21. So 21 is my first integer. When you add 2 to that, what do you get? 23. When you add another 2, you get 25. When you add another one, you get 27. Good. Now, I would pause here. Are these all odd numbers? Yeah. When you add them together, do you get 96? Yeah. So you can be done and you can be confident. These always drive me kind of crazy when students get the wrong answer because I'm like, these are so easy to check. Like, you can add 4 numbers. I know you can. You have a calculator. You can tell if numbers are even odd. I mean, you're in high school. So these are, you should be working these and working these and working these and working these until you find something that works out. You should know if you did it wrong before you turn it in. Questions? These are hard though, but they're easy to check. Final example of the day. Triple the smallest of 3 consecutive integers is 4 less than the sum of the other 2. Boom. This is going to be hard. 3. Okay, so triple the smallest of 3 consecutive integers. Right away, I see 3 consecutive integers. I'm just going to focus in on this. 3 consecutive integers. So the first one is going to be what? X. The second one is going to be x plus 1. The third one is going to be x plus 2. Triple the smallest is. Triple the smallest of these integers is. So what do I have so far? Triple. Multiply by what? 3. Which one's the smallest? The first one, right? So triple the x. How would I write that? 3x is.
4.
No, is my what? The equal sign. So that's like the first break in the problem. Okay? 4 less than. I know that means at the end of the problem, I'm going to have a minus 4. The sum of the other two. Sum means what? Add. The other two are the x plus 1 and the x plus 2. So here's my equation. Triple the smallest is 4 less than the sum of the other two. All right, and now I can just start working it out. So 3 times x is 3x. On the right side, you have some like terms. So x plus x is 2x. And then I have 1 plus 2, which is 3, minus 4, which is negative 1. When my computer decides, whoa. Whoa! It's going to make me do some work here. All right, so 3x equals, combine, 2x. Now, normally we would do just the parentheses and then subtract the 4, but can I do them all together? Mm-hmm. Okay, so what's 1 plus 2? 3 minus 4, what did we say? Negative 1, good. All right, get those x's on the same side of the equal sign. We haven't done this yet. We haven't done variables on both sides. So this is kind of a preview for next week as well. If it's a positive 2x and you want to move it to the other side of the equal sign, you subtract it, okay? 3x minus 2x is 1x, and that equals the negative sticks with the 1. So my first integer is negative 1. What's the next integer after a negative 1? A 0. Yes. And then a 1. Okay, this one's a little harder to check, but I'm going to see if I can do it. Triple the smallest. Triple the smallest would be 3 times negative 1, which is negative 3. That should equal 4 less than what I get when I add these two. What's 0 plus 1? And what's 1 minus 4? Negative 3. So this does check out. It's kind of difficult to check, but it does check out. Questions? All right, today we learned
How to solve integers. Or how to do it.
consecutive integer problems. Very good. I would actually just say like word problems. Or writing equations to solve word problems. But basically we just did all the word problems from yesterday, just in more detail. All right, here comes your homework.